take a look at that. Peter purchased P pencils for D dollars. If the pencils had cost X more dollars, how many pencils could Peter have purchased for $20? All right, so what we've got here is we're going to do another chart, okay? We're going to start with our original situation and the new situation, very similarly to the last type of problems that we've done there. Okay, but with the last ones, we always use distance, rate, and time. That's not going to work here, is it? Okay, we need to come up with another generic equation here. All right, and if you think about this, you guys already do this stuff. When you buy so many of a certain thing, you try and figure out how much it costs. All right, so what I'm going to say instead of distance, rate, and time, like we normally do, is we're going to say instead of distance, that's going to be the total cost here. Okay, our rate still stays the same. That's how much, in this case, how much each pencil costs. And then the time, well, it's not going to be time. It's going to be more like items here. Okay, so we're just going to change it up a little bit, but think about it. If you buy 6 items at $2 a piece, you guys all know that it's going to cost $12 total. Okay, so that's where that equation kind of comes from. All right, so we're going to have C, R, and I here. All right, so we've got to figure out what our original information is. We have P pencils. Well, those are our items. P is going to go in to where we see an I there. All right, 4, D dollars. What do you think the D, where do you think the D goes? Into the cost, yeah. All right, so then if we just have that, what is our rate here? D over P, yeah. Okay, now some of you ask me quite often, all right, I think you do this, but sometimes it feels like you do this. All right, if for one of these problems that we did in the past, we could figure, if you can figure out what the rate is, figure it out. Okay, so for example, if you knew that this was a 12 and this was a 6, you can figure out that the rate has to be a 2. Okay, don't put these variables in there. Just figure out what the actual amount is. If you can't figure it out, like what we have here, we're given variables for everything, then use those variables to solve for your rate. All right, now we need to go and figure out what changes. Okay, now before you figure out what changes, we got to figure out what we're solving for. It says how many pencils. That's our items. We're going to put our question mark in there for the items. Okay, I like to do that first, so then I don't put something in that spot and confuse me later. All right, now, things that we do know. We've got $20 to spend. Where's that $20 going to go? It's going to go into the cost. All right, if the pencils had cost X more dollars. What's that, Max? That would be correct. Well, yes. D over P plus X. All right. So then we can come up with an equation here. We've got 20. Our cost equals our rate times the number of items. All right, now from here, you guys all know we just got to get the question mark by itself. All right, what I would do before I move this to the other side, I would get this into one fraction. So we've got to have a common denominator of P. And what that means is this X, we've got to take times P over P there. All right, so this would end up being D plus XP over P equals 20. And then we've got our question mark there. All right, to get the question mark by itself, we just multiply by the reciprocal, right? So P over D plus XP. So our question mark is by itself. On the top, we've got 20P over D plus XP. All right, and then I should probably have a label on there, shouldn't I? What did we solve for here? Pencils. All right, so these, if I gave you numbers for each one of these, most of you guys are going to be able to figure it out pretty quick. All right, the hard part about this is there are very few numbers in this problem. All right, but the thing to realize is we do it the exact same way, whether it's numbers or variables. Okay. Can you think of any questions up there? All right, build your chart. Once you build your chart, it's going to kind of tell you what you need to do. The chart part ends up being kind of the hardest thing here. Brett, you got it all written down, huh? That's good. Nice and quick. All right, you guys can already see as we're writing it down, we've got a few variables in there. All right, and we've got a couple more, or we've got another number in there to be able to deal with here. It's kind of the same concept though. What's our equation going to be for this one? Is it going to be distance, rate, and time? No. It's going to be kind of the same thing as the last one, right? So I'm going to put down cost, rate, and items. Our items happen to be our basketballs for this one. All right, so the coach purchased B basketballs. So that's going to go into our items for X dollars. Does the X go into the rate or the total cost? Total cost. All right, so then we can figure out what the rate is. The rate is what? X over B. Very good. All right, so the original is all taken care of. All right, now what are we solving for here? Yep, how many basketballs? So we're figuring out the items again here. What do we know for sure? Cost is 200. All right, and then the other thing that we have here is if each basketball had cost $3 less. So how's that going to affect our rate? X over B minus 3. All right, chart's filled in. There's our equation, 200 equals X over B minus 3 times our question mark. Kind of the same concept as the last time. We got to get common denominators here. So we're going to multiply top and bottom by B here. So we've got 200 equals X minus 3B over B times the number of basketballs. And then we just multiply by our reciprocal on both sides. So we get 200b over x minus 3b basketballs. All right, any questions? Honestly, we're not doing anything different than what we've done in the past. It's just all variables now instead of having numbers in there for most of the stuff. Okay, it's all the same. Okay, but as I said earlier, when we're throwing nothing but variables in here, that confuses a lot of us. Okay, me included sometimes. All right, make sure you're working on those. All right, we'll go to the next one. Last one for this lesson. Like I said, next lesson is easier. Not a single number up there at all. As you're writing it down, think about what kind of equation we're going to have to use for this one. Jordan's got it? Well, don't share that knowledge quite yet. Let everybody else think. Max agrees, though, is what I got out of that. All right, Miss Sunram thinks she has the equation. You want to share with everybody? Why is it J word? And that, yeah, it's normally, when it says something about workers there, that's normally a good way to go. So we're going to have down the side here is going to be our J word. I would agree. All right, we have our original and our new. All right, so as Jordan said, our M is going to be our workers. Hours is normally time, so that H is going to go there. Where's the C going to go? It's going to go into jobs, yeah. All right, so then what is our rate here? C over MH, yeah. Okay, now sometimes that can be kind of hard to figure out. Remember, it's J equals WRT. So if you have to write this down to figure it out here, go ahead. All right, you guys all know that to get the question mark by itself, we're going to have to divide by the M and divide by the H. Okay, most of the time I skip that because a lot of you guys know that, but if you have to write it down, write it down. All right, so from there, we got to figure out what changes here. If D workers quit, what does that mean? M minus D for our workers, yeah. How many hours? So that's going to be what our question mark is, right? So our question mark is for the time. Would the remaining workers have to work to produce the same number of articles? So our jobs don't change, does it? What are we going to put in for a rate, though? Did they say anything about rate? If they don't say anything about the rate, we're going to assume that it stays the same. All right, so then there's our equation. All right, so we're going to divide the m minus d over. So we get c over m minus d equals c times mh over a question mark. And then multiply by the reciprocal, we get mhc on the top times c over m minus d. I wrote it that way on purpose. Why did I write it that way? Yeah, our c's are going to cancel here. So that's going to go away and that's going to go away. Equals our question mark. So we've got mh over m minus d. And what do I put after that? Hours. All right, this one is always interesting to me as the former engineer type, where this would be our answer. But it's interesting to me that notice that M stands for workers and D stands for workers. And our H was the number of original hours. We're supposed to figure out how to get the job done. It doesn't say anything in that answer about the actual job itself. So because they ended up canceling out like that. All right, so there's the first one. All right, build the chart. Once you build the chart, you have the equation there. All right, they're not easy though. Okay, I do expect questions off of these. All right, and so make sure you get that taken care of. All right, we'll go on to the next one. They are word problems, but they're a whole lot easier word problems. So conditional permutations. All right, the other day we talked about permutations. The equation, who remembers what the equation is? I'll help you out. NPR, what's the equation part of that though? N factorial over n minus r factorial. Okay, just remember, all right, just have that down just in case that gets thrown on that no calculator test. Okay, I don't remember if it's on the test or not. All right, and even saying all that stuff, we're not even going to use that today, or at least not for this first one. How many odd counting numbers can be formed from the digits 3, 4, and 5 if no repetition of digits is permitted? All right, now this word right here is the most important word in this entire problem. It's got to be odd, meaning the last number has to be an odd, right? So, for example, give me a number using those 3 digits that would work for this. 345. Give me some more. Let's see if we can get them all without doing any math. 543. Okay. What else? Say that again. 435. Yeah. What else? 453. Anything else? That's it? Okay. Well, let's see if we can do this math-wise. I think that's right. Let's see that we can do this math-wise another way, see if we get the exact same answer. Because when you only have 3 numbers like this, it's really easy to just list them out, say, all right, the answer is 4. All right, but say that I make it a little bit more complicated. And the only way you know how to do it is to list them all out. All right, and you start listing them all on a test, and it takes you 20 minutes to do a problem, but you're 100% positive you're going to get the right thing until you miss one number, and then you're going to be really frustrated, right? Okay, so there is another way to do this. Okay, what we know for sure here is we know that there's going to be a 3-digit number here. Okay, and what we know for sure is, I already said this is the most important word in that entire problem. Okay, how do we tell that something is odd? This digit right here has to be odd. How many odd numbers do we have in our list? We have 2 of them, so we're going to fill this in first. Normally, we start from the left and go to the right, but this time we have to start with what's most important. Okay, now we can either go to this number or this number at this point. It doesn't matter which one. Okay, say we pick a number that it falls in here. How many numbers do we have left for the next spot? 2, right? If we choose a 3 for this number, we've still got either a 4 or a 5 here. If we choose a 5 for this number, we still either have a 3 or a 4 here. All right, you're going to have 2 options no matter what. Okay, so that's where this 2 comes from. All right, once we choose this number and this number, how many do we have left? 1. What do you do with those numbers? Multiply them. All right, and how do we know that it's multiply? That's the second most important word up there. You guys remember from before? It's been a while. One word, I heard it. And, yep. This is the second most important word here. All right, if it says and, you multiply. All right, what means to add them? 4. All right, if that were to say 3, 4, or 5, then you would add them together. All right, so put that somewhere important in your notes so that you can find it. Okay, we have talked about it before, so hopefully it's in your brain somewhere. All right, but then all you do with these 3 numbers, you multiply them together. Hey, look at that. That answer matches up with what you guys said before. Okay, so what that means more than anything else is because we did it 2 different ways, we got the same answer. Both ways work. Okay, all right, so let's make it a little bit more complicated then. All right, just write down the first one. I'll give you time to copy down the second one afterwards. All right, just in case. I don't remember how much room this one takes. Find the number of even 3-digit counting numbers that are less than 300. All right, now this time I'm not going to list them all. There's too many of them. I don't want to list them all. All right, but what I do need to know is how many blanks am I putting down here? 3. We know that because it's a 3-digit number. Okay, that will be important later on. Okay, now, most important word there is what? Even. We've got to deal with the even first. All right, which means back here, we're going to have how many numbers go into this? We're going to have how many even numbers are there? Maybe. We don't know that yet. Just in this spot, though, Max. Just in the ones digit. We're going to have 5 of them, right? 0, 2, 4, 6, and 8. So we've got 5 of them. All right, now we're going to go to this one. Does it say anything about we can't repeat a number? No, so we can use all of them. How many numbers would go here? Which one did you forget? You forgot 0, right? 0 is a number. Okay, so we would have 10 of them that go here. All right. So normally it is the 0 that gets forgotten. So we've got a 10 here. All right. Okay. All right. What number is going to go here? What do you think? Stetson, what are you saying? Why is it a 2? Well, that's a good question. Okay, Max asked a very good question there. Can we put a 0 into this spot? Why not? It's not 3-digit, right? If you put a 0 here, then it's just a 2-digit number, right? So the only numbers we can put here is 1 and 2. So we only have 2 numbers that go there. All right, what do we do with those numbers? We multiply them together. So what do we get? We get 100 of them. All right. Max, you understand why it's not 149.9? Yeah. Now, if this goes away, does that change your answer by a lot? Yeah, we'll talk about that later. We won't deal with that right now. Yes. Yeah. Yep. Yeah. So that 3 was very important for that too. All right. How we doing? We doing all right? Okay. Go ahead and copy down the next one. A little bit longer here. All right, 7 fiction books and 3 nonfiction books are lined up on a shelf. How many different ways can these books be lined up if the fiction and nonfiction have to be kept together? That's a very important part here. Okay, so what I mean is we line up our fiction books first. So we're going to have all 7 of them first, and then our nonfictions after that, right? Okay, so if we did that, let's think through this. In this first slot for fiction, how many books do I have there to choose from? 7. Once I put 1 book there, how many can go into the next spot? Next one. So this would be all the way down, right? Okay. So if you were to simplify that, we just say that's 7 factorial, right? What about the nonfiction? How many options do we have for the first one? 3, 2, and 1, right? So we would have 3 factorial there. All right, now, what do we do with those numbers? Which one? I heard both. Why is a multiply? Yep. There's our important word there. So we've got 7 factorial times 3 factorial. I don't remember what that is. Thank you. 30,240. All right. Is that our final answer? Max thinks it's a different one. What do you think?
Different ways.
Oh, different ways? Well, I would say, is that the right number? Okay, how about that? What do you mean, Jordan? Sure, you could. You could do nonfiction first and then fiction after that, right? So then all we're doing is we're not changing any of the numbers, right? We're just saying first, we're going to have 3 factorial, and then we're going to have 7 factorial, aren't we? We're going to do it the exact same way. We're still going to get 30,240. We just have to add those together. So we get 60,480 different ways to line up those books. All right. That's the part that normally gets forgotten. All right, is we've got to think through all of the different options that are available. Okay, so for this one, we just have to reverse the order there. Okay, how are we doing with this? For this one, honestly, I haven't taught you anything new, have I? Okay, it's just how the problems are worded. We're just trying to solve word problems here. Okay. All right, this one, write it down. This one's a little bit longer here. Students A, B, C, D, E, and F were to sit in a line. How many different ways can they be lined up? If you have to have those 2 kids that just have to sit next to each other. Yep, so Jordan and Kayla have to sit next to each other. We're going to call you A and C, though. All right, now this is where it does get a little annoying, is when you have that exact situation. They have to sit next to each other. They don't really care where they sit. They just got to sit next to each other. It's going to give lots of different options here, okay? And there ends up being a pattern to this one. So once you see the pattern, you can kind of stop doing it, but we've got to get an idea first before we can even see what that pattern is. All right, so let's say right away, we've got these 6 seats here. All right, and we're going to say, all right, A is going to sit right here. Well, if A sits here, who's got to sit right here? C has got to sit there. Do the other 4 chairs, does it matter? No, so how many kids could sit here? 4, and then 3, and then 2, and then 1, right? Okay, and technically, because this is an A, that would be, if we're looking for a number there, that'd be 1 person. And for our C spot, that would be another person. And then we just multiply all of those numbers together. So 4 factorial would be a 24. Now that is not the only place that they can sit, though, is there? Okay, A and C could just switch spots, couldn't they? They could switch there. And then we've got 4, 3, 2, and 1. So we've got another 24 there. All right, well, if A sits in the second spot, C doesn't have to sit on the left side. They could also sit on the right side, couldn't they? All right, the other 4 kids, it doesn't matter. So this would be 4, 3, 2, and 1. So this would be another 24. Now what we're seeing here is our answer is always going to be 24 for each way that these two kids sit. We've just got to figure out how many different ways they can sit in the entire thing, right? All right. So say that you don't know, but what we're starting to figure out is this 4, 3, 2, and 1 doesn't matter. All right. Well, A started here, and then they switched. Okay. And then they're here. They could also switch, couldn't they? That's another 24. All right. C's on the left side. Say they want to sit on the right side. There's another 24. All right. And then say these two switch. There's another 24. Instead of the left, say they're on the right. And then they switch. Almost done. And then C has to sit on the right side. So we've got A and C here. And then those two switch. How many different ways can A and C sit? There are 10 different ways that they can sit there in those 6 chairs. 2 still sit next to each other. All right, so then we just take that 10 times the 24 there. So 240 different ways. All right. Some of you are going to see the quick way to do it. Some of you it'll take a little bit more. It's okay. Okay, it doesn't matter which way you go. All right, what ends up happening here is in those 2 spots, those 2 work together. How many different ways are they going to work together? So there's our second one, our third one, our fourth one, and our fifth one. And inside of each one of those, there's 2 different ways. So that's where we get the 10 from. All right. If you have to list those out, list them out though. Okay. All right. Any questions? All right. Write it down. Just write them down. Yeah, you're going to need another page, Jordan. You'll be okay. I know. It's just terrible. Waste of paper because I can't continue my notes for Friday right below it. No, of course not. All right. Now, before, we've already done these. Okay, we've done line of best fit before. All right, and the problem with what we did before was it was an estimate. It was a guess. Yours could be very different than the person next to you. All right, but there is an actual way to find the absolute actual line of best fit. What it's called is it's called a linear regression model. Okay, and all that means is that you would use your calculator to be able to find what the actual slope is and what the y-intercept is. All right. Now, the directions to do this are in the book. They're exactly the same. All right, but I'm going to show this to you really quick, hopefully. Awesome. Maybe that was. Let's calculate. There we go. All right, so what we have up there is we have 5 points up there, right? Okay, now all your graphing calculators have this capability of doing this. Okay, so the TI Inspires, I haven't figured out how to do it yet. Okay, I haven't really looked into it, but we'll figure it out. I know it's not that hard. Okay, for those of you who have either the yellow ones or pretty much all the rest of the graphing calculators, the process for it is we need to go to statistics. So stat. Right, so that's the first thing, you go to stat. And then what we want to do is we want to put those numbers in there. So if you look at, if you go over to calculate, what this does is it's going to calculate a lot of different things in here. All right, and what we want to find here is we want to find what's called the linear regression. So at some point, we're going to use this number 4 option here off of your calculator. All right, but before we do that, we've got to be able to plug in those 5 points. Okay, now if you look right above your stat button on the calculator, you'll see the word list. All right, and if you go to that, we are going to, that's not right, hold on a sec. No, I was right the first time around. Yes. Okay. Stat. Okay, don't worry about the list thing, that was for something else, that's my bad. All right, so the very first option here is edit. That's what we want to do first. We want to hit enter on the edit here. So then we get a chart that looks something like this. Okay, I have previous numbers in there. If you have previous numbers in there, you can just hit the delete button and that'll get rid of everything. Okay, if you don't want to delete it, that's fine. We'll just type right over the top of it. Now, our L1 and our L2 is what we're going to use here. What we're going to do for L1 is we're going to put in all of our X values. All right, so we put in those 5 numbers for our X values. Or our Y values. Those are going to go into the L2 column. All right, so what you should have here is you should have those 5 points put in there. All right, any questions so far? Yes. Okay, you're at the stat button. Okay, you see how edit is highlighted? You hit enter. And then you put the numbers in there. Okay, so once you get the numbers in there now, for those of you without, I told you you need one of these at some point. Okay, for your tiny, I'm going to call them tiny little calculators because that's what they are. They're not very powerful. Okay, those calculators not going to be able to do this. Okay, so once we get those in there, then calculator is going to do the rest of the work for us. Okay, we just have to go back to stat after we get those in there. Go back to stat. And then we're going to go over to calculate. And then we're going to come down here to this linear regression like we talked about earlier. We hit enter. All right. Our X, that X list, that's where we put the X values. So we want to make sure it's L1 there. All right. If it's not L1, you can type it in there. All right. Our y values are at L2. Okay, and then we come all the way down here to calculate. And we hit enter. And there's our slope and our y-intercept. So our answer, our exact answer for this one would be y equals negative 0.2075 x plus 25.64. Okay, yes, ma'am.
Mine doesn't say that.
Yours did not say that.
Mine didn't
yours
say that either.
Then this much.
Okay, so what that means is if you got that, that means that these did not match up. Okay, you did not have just these 5 numbers in here.
Can you go back?
Stat, edit,
Oh, wait. Quit.
yep, we did that.
Mine doesn't.
Oh, there you go, perfect. Yeah, you just go down and calculate. Yes, we're gonna talk about that in just a second.
I think I have it all.
I'm just saying. Okay, Kayla, you got it all figured out on that one? Not quite, getting there? I'm saying.
I go down. What?
Sometimes I have no idea what I'm clicking
Alright, ladies and gentlemen, okay, close your mouths, please. Now, what this tells us, this tells us here is that tells us what our slope and our y-intercept are, okay, of the actual line of best fits. They averaged all of those points together and they gave us the best line of best fit, okay? So like I said, this is y equals negative 0.2075 x plus 25.64. Now, there are lines of best fit that are really good, and there are lines of best fits that aren't. Okay? We have to have one more thing thrown in here to be able to tell that. Okay? And Stetson, you had it on your calculator. What is that value? Which one? We've done it before, that's why I'm asking. Which one is it? Which one's important? R or the R squared? Huh? No, not the R squared. It's the other one. Yes, it's the R. Now, some of you don't have that on your calculator. How do we get that? What I need you to do is I need you to go right above the 0 button. Okay, as you guys can see, I don't have it on my calculator right now. Okay, if you don't have it, right above the 0 button is the catalog. All right, so you hit second and then catalog and you should get this. Okay, and then we have to go down quite a ways. What you need to do is you need to go all the way down to what's called diagnostic on. Okay, and once you get there, you just hit enter twice. And when it says done, now it'll figure it out for you. Okay, So now we just go back to stats, calculate. We're going to do that linear regression again. And now I get that number that Stetson was talking about. Okay. Now, in the past, we have talked about what R means. R tells us how close to the line those points are. All right. Now, R is always between 1 and -1. Always between 1 and -1. The closer, now, how you tell whether it's a positive or a negative is based on your slope. Our slope is negative, so our R value has to be negative. Okay? Now from there, how we tell how good this line is, the closer this number is to 1 or -1, the better the line is. So because this is fairly close, this is a fairly good line of best fit. Okay? If this were really close to 0, then it's a terrible one. Okay? What that would mean on a chart, if you were to just put a whole bunch of points on a graph, if this were, say, like a 0.2, it would kind of look like a scatter plot. It would be all over the place. You kind of put a line through the middle of it, but you don't really know if that's the right one or not. Okay? That's what it would look like if it's close to 0. So like 0.1, -0.1, 0.2, -0.2. If it's really close to 1 or -1 like this one is, what that means is when we draw that line through those 5 points, all 5 of those points are going to be really close to the line. Okay? And this is how you get the actual line. Okay? Any questions?
So what were you writing down?
So, for a line of best fit, we talked about this is your equation, right? And then the question is always going to be how good of a line is this? So they're going to ask us something similar to that, okay? And you would say because R is -0.78, it is a pretty good line of best fit. Okay. All right. Do you guys have questions for me?
So you just want us to write down the line equation?
No. Well, it depends on what you're asked in the homework. For this one, I just said line of best fit. But in the homework, they might ask, how good of a line is this? And then you would say, because R is -0.78, then it's a pretty good line of best fit.
But for this one,
Okay? Now, how are you going to do this problem if you don't have that tool? Good luck. Okay? And I told you guys that on day 1. Okay? We would use it sometimes. I didn't say we were going to use it every day, did I?
No.
Okay? So it's kind of up to you. I still have calculators back there that I can hand out. Okay? $10 a piece. Unfortunately. Well, you got to deal with it. It might be the difference between passing and failing, right? Maybe. Your choice. I'm not going to make that choice for you. You make the adult decision. All right, questions for me? All right, homework. A25 from, what do we have, 44 and 45. Okay, quiz. Next week, Tuesday, you guys, yours will be on lesson 44. Okay, all right, any questions there at all? All right, you guys have 20 minutes or so to get stuff out, get it done. All right, Sarah and Elena are taking their tests later today. So that means I can give you, as soon as they take their test, I can give you your test back. All right, so as soon as they take it, I'll send you an email through Schoology saying you can come grab your test. All right, and then test next week, Thursday. Mrs. Lemke wants to see a few of you. I don't remember who though. Let's see. Graham, Sarah, Abby, and Hannah to Mrs. Lemke's office right now. Yep. I haven't looked yet.
No, it's stuck I'm stuck on press the test.
What?
So I'm stuck with the test. I don't know what I did, but I can't get off of it.
You can't get out of it?
No, I went through everything. There's no option for me to get out of it.
Oh, you broke your calculator before you figured out how to use it,
Like
huh?
when I turned it on, it was the only option.
That's weird. All right, let's see. How do you reset this stupid thing then? Well, unless it's...
I don't know why you're doing that. Can I go back?
Yeah. Yes, ma'am.
Can I take my test?
Yes. Sarah's not going to take it yet. There we go.
That's Sarah.
I knew that. Max confused me. All right, people, let's go. You got 20 minutes. A lot of you actually need to do homework instead of figure out a way to copy it. Yes, I'm not dumb. I know that's what's going on, and I know that's what's causing a lot of the homework issues that go along with it. Okay, fix it.